Namaste. My name is JVN Manisha Singh, Assistant Professor in Department of Food and Biotechnology under Faculty of Agriculture and Veterinary Sciences in Jyoti Vidyapeeth Women's University, Jaipur. I am teaching you subject Unit Operations in Food Industries for class BSc FST second semester and BTech FBT second semester. In previous session, we were study all about the heat exchangers. In today's session, we will study the equilibrium moisture content and the moisture content and the water activity of the food. Okay, so let's begin the topic with the equilibrium moisture content. So what is this? Every food exerts a characteristic vapor pressure at a certain temperature and the moisture content. Okay, so all the porous foods, when in contact with the moist air, absorb or desorb water molecules to attain the equilibrium moisture content. Okay, so this equilibrium moisture content depends very strongly on the partial pressure of the water vapor in the surrounding air and rather weakly on the air temperature that are commonly experienced in drying and storage of foods. Okay, so if the moisture content of the food material does not vary with the time for a given combination of water vapor pressure and air temperature, then it is then said that it has reached the equilibrium moisture content of the material at that water vapor pressure and the temperature. When left undisturbed, the natural end of any adsorption or desorption process is the attainment of equilibrium moisture content. This, though a natural process, is often very slow. Food materials take several days or weeks to reach the equilibrium. When the water vapor of the air approaches the saturation water vapor pressure at the temperature of the air, the equilibrium moisture content of the food materials rapidly increases. Okay, so at these stages, the process undergone by the food material is not only the adsorption, water vapor begins to condense within the pore structures of the building materials. Theoretically, if the food material is in contact with the air in that 100% saturated for a very long period, all pores of the material should be filled with the condensed moisture. Okay, so the equilibrium moisture content that corresponds to the hypothetical state is called the saturation moisture content of the material. But in practice, the rate of this process becomes infinitesimally small at an equilibrium moisture content that is known as the capillary saturation moisture content and is often substantially less than the saturation moisture content referred to above. Okay. The drying of grain involves exposing grain to ambient air with low relative humidity or to heated air. This will evaporate the moisture from the grain and then the drying air will remove the moisture from the grain bulk. Since drying practices can have a big impact on the grain quality or seed quality, it is important to understand some fundamentals of the grain drying. Okay, so the concept of equilibrium moisture content is important in the study of drying and storage of fruits, vegetables, and grains. The equilibrium moisture contents helps to decide the stability of food at particular moisture content in the given environment. The equilibrium moisture content values of several grains and foods have been determined by several research workers and reported in the literature. If exposed to air, high moisture foods lose moisture, whereas low moisture foods gain moisture in humid air. Okay, equilibrium moisture content determines the minimum moisture content to which food can be dried under a given set of conditions. Also, it determines the maximum amount of moisture the dehydrated food can absorb during the storage. The equilibrium moisture content can be elaborated by an example which is given by Hall in 1980. If wheat and oats having 16% of moisture content and are kept in the environment of 86 degrees Celsius and 75% relative humidity, wheat will absorb moisture and oats will lose. And this is because there is a different vapor pressure of the moisture in wheat and the oat. Okay. At the above air temperature and humidity of the vapor pressure of the wheat is 0.444 psi and oat is 0.77 psi. Whereas the vapor pressure of the moisture in air at 86 degrees Celsius and 75% relative humidity is 0.461 psi. Therefore, wheat will gain moisture from air as vapor pressure of air is more than wheat. At the same time, oat will lose moisture as its vapor pressure is higher than air, and there is always a tendency of movement of moisture from higher vapor pressure to the lower vapor pressure. Now, when the vapor pressure of the air held by the food particles becomes equal to the water vapor pressure of the surrounding air, the movement of moisture stops and comes to the equilibrium. At this moment, the food product remains at the same moisture content in the same air temperature and the humidity. And this moisture is known as equilibrium moisture content. Okay, the relative humidity of the air surrounding the food particles at the same conditions is called equilibrium relative humidity, and which is also known as water activity. So factors affecting the EMC is air temperature and the relative humidity. Okay. Now, next topic is the water activity. So, as you all know, all foods contain at least some water, and it may be in the free water or in the bound water. Free water is something which is held inside the cells and maintains the properties of free water and may be removed when we apply pressure. Okay. And the bound water is a part of molecular structure which reduces the mobility and does not retain properties of the free water. Okay. So water activity is the amount of free or available water in a product as opposed to the bound water, and water activity is the measure of the energy status of the water in a system and the ratio of vapor pressure of water in a food at a specified temperature to the vapor pressure of pure water at the same temperature. Then, why water activity is important? Water activity is one of the critical factors in determining the quality and safety of the foods. Water activity affects the shelf life, safety, texture, flavor, and smell of the foods. Okay. While temperature, pH, and several other factors can influence if and how fast organisms will grow in a product, water activity may be the most important factor in controlling the spoilage. Most bacteria, for example, do not grow at water activities below 0.91, and most molds cease to grow at water activities below 0.80. By measuring the water activity, it is possible to predict which microorganisms will and will not be potential sources of storage. Water activity, not water content, determines the lower limit of available water for the microbial growth. In addition to influencing microbial spoilage, water activity play a significant role in determining the activity of enzymes and vitamins in foods and can have a major impact on their color, taste, and aroma. Okay, the water activity measurement is done by the three methods, that is the resistive electrolytic hygrometers, capacitance hygrometer, and the dew point hygrometers. In resistive electrolytic hygrometers, it consists of potentiometer, that is sample holder and sensor with immobilized electrolyte, for example, lithium chloride. And its changes in ERH are reflected in changes in conductance of current through sensor and typically slow and requires routine calibration with the standards. Okay. Next is capacitance hygrometers. It consists of two charge plates separated by a polymer membrane that is a dielectric. As the membrane absorbs water, its ability to hold a charge increases and the capacitance is measured. And this value is roughly proportional to the water activity as determined by a sensor specific calibration. Capacitance hygrometers are not affected by most volatile chemicals and they do not require cleaning but are less accurate than the dew point hygrometers. Dew point hygrometers use as a cooled mirror as condensing surface mirrors is cooled. Their condensation is occurs. The temperature is equal to dew point and equilibrium uh, relative humidity is derived from psychrometric chart and it is very fast and accurate and calibration is not needed in this by this method. So factors affecting water activity is drying. Water activity is decreased by physically removing water. Solutes. Water activity is decreased by adding solutes such as salt or sugar. Freezing. Water activity is decreased by freezing and combination one or more of the above can be combined from a greater influence on water activity. Water content or moisture content is the quantity of water contained in a material and water activity is related to water content in a non-linear relationship known as moisture absorption isotherm curve. And these isotherms are substance and temperature specific and isotherms can be used to help predict product stability over time in different storage conditions. Okay. So cooked meat and bread have water activity 0.91 to 0.95. Fresh raw fruits, vegetables and meat fish have water activity 0.98. Then cured meat cheeses 0.91 to 0.95, jams 0.75 to 0.80, dry cereals 0.65 to 0.75, etc. And bacteria grow in Staphylococcus aureus is 0.86, Halobacterium species 0.75. For mold, aspergillus flavus can grow at 0.78 water activity and Xeromyces bisporus at 0.61 and yeast like Torolopsis species 0.70 and Zygosaccharomyces belli is at 0.80 and Zygosaccharomyces roxy at 0.62 water activity. Okay, so from this session, questions may be asked in your final exam like explain the equilibrium, moisture content, and the difference with example. So you have to explain the example given by the halls and in briefly and question also asked like what is the moisture content, explain water activity, how to measure water activity, etc. Likewise question will be asked in your entrance point of view. In your entrance exam, question may be asked like at which water activity bacteria can grow, at which water activity molds can grow. Okay, likewise question will be asked in your entrance exam, so prepare accordingly. And thank you so much. I hope all is clear to all. This session is clear to all. Thank you so much for watching this video.